Hi guys, welcome. So today we're going to learn how to do all of this crazy stuff for question 1 together. That was the wrong side. Oh no. Okay, so let's get right into it. Before we can solve any of the questions, we have to get the equations for the position at all times t and the velocity at all times t. We will be using that to solve for v of t and r of t. Take the integral of a of t, solve it, and you will be given the answer of v of t. To find the equation for r of t, you have to take the antiderivative of v of t. Once you solve for both of those equations, you have what you need to answer the question. It's important to understand that the home plate is at x equals 60. So we are going to be using our x component to solve for t when x is equal to 60. Now for part 2, what you would have to do is use the vertical component, which is denoted here with z. Now you would do a similar process where you just simply replace t with the time that you were able to obtain from the first part. Now that we've noted that our new vertical component will be represented by a variable for the time being, we can use this information to solve for what that variable will be. So the vertical component is denoted by the z-axis, the z component. So what we have to do is set z equal to 2 because that is where they want the ball to be above ground. And we set our z component equal to that. Now for t, we are using the same time t that it takes to cross the home plate. Now when using algebra, you get to solve everything and you come out with a figure that k is equal to negative 2.476 feet per second. We have to take into account that the curve is in the y direction. So that means that we are going to be replacing what used to be 0 in our acceleration vector with the value of c, which was given to us as 8. So our new acceleration vector is 0, 8, negative 32, and we're going to use that to solve for what the velocity will be in the y direction. To find the new velocity by taking the integral of a of t, you will get a new equation that reflects the sideways acceleration, noted right here. It's a position vector. Now, we are going to use that part of the equation and find what the value is during the times from t of 0 to t is 60 divided by 140. To solve algebraically, you will be left with the number 0.7346. We're going to take into consideration both halves of the flight in terms of time. And so the first half would be from 0 to 30 over 140, and the second half would be from 30 to 60 over 140. So to actually solve it, you would just plug in the value of the times within the y direction. The question does say refer to part C, so that is why we did that, so that we would just have that equation, just bring it down here and use our new times to fill in the variable of t. Now, when you do solve for that, you will find that the second half has a greater decimal number. It is negative, however, we're talking about magnitude here, so it is greater in magnitude. As usual, we are going to be finding a new equation so that we could apply these new parameters to. So you take the integral of the acceleration to find the new velocity, and you can take the integral of that to get a new position vector. We are focusing on the y component. Remember, that is the curvature that is caused by the spin. So, since we have our y component there, we're going to go ahead and insert the values that we know and solve. Now let's find where we do that. E. This is E? Yes, okay. Okay, so once we have it known that we are going to be using the y component to solve for c, we are going to set it equal to 0. That's because the point that we want it to be at has the y equal to 0. So we're going to go ahead and set our y equation equal to 0 and solve for c. Now this is ugly little algebra that I did, but you could go ahead and plug it into your calculator and you'll get 32.67. Just another reminder, the t that we are using is the t that we found at the beginning in letter A, just so there's no confusion. But yes, congratulations, you just finished all 15,000 glorious parts of question 1. Good job, I'm proud of you. I hope you have a good one. Have a good time.